We saw in the previous video how to convert from octal to decimal. Now let's use that same multiplication algorithm to convert between hex, so a base 16 number, to decimal, a base 10. So here's the formula. Suppose we have a hex number. So given a number, let's just say the digits are W, X, Y, Z. This is a 4-digit number for my example, but you can do this with any length of digits. So for the first step is we're going to write out the digits of our hex number with placeholder subscripts. So we're going to start at 0 at the least significant bit position, and we're going to increase as we move to the left. Okay, great. And then step 2, just like we did in the last example, is we're going to multiply each digit by, this time it's going to be different. Instead of 8 raised to the subscript, it's going to be 16 raised to the subscript. And that's because this is a base 16 number. Okay, so the B is going to change. So this is what it looks like. If here's our hex number, here are our placeholder subscripts. I'm going to take whatever that digit is, Z, and I'm going to multiply by 16 raised to the 0 because 0 is the subscript on Z. Then I'm going to take Y and multiply by 16 to the first, and then X gets multiplied by 16 to the second because 2 is a subscript on the X, and then W gets multiplied by 16 to the third. All right, and then the third step is to get the result of our conversion to decimal. We just add up all these products. So whatever that is, whatever that is, whatever that is, whatever that is, we just add them all up. So the result of the conversion is the sum of all the products. Okay, so let's see a couple examples. We'll do one small, easy one, and then we'll do a harder, more complicated one. So for example 1, let's convert 6D in hex to decimal. Okay, so we're going to write out the digits of our hex number. Now, something that's kind of interesting, if you see a D here, you remember in hex, the building blocks of hex are the numerals we have at our disposal are the same 4, 5, 6, 7, 8, 9 as decimal, but then we have some additional, right? We've got A, B, C, D, E, and F. So these are our building block fundamental numerals that we can represent any hex number in. So if you see, if you have to convert a hex number that actually has a letter in it, just keep in mind that this is sort of like the decimal equivalent of 10. This is like 11, this is 12, this is 13, this is 14, and this is 15, right? So this can be written as, this D is, it's like a 13. So we're not going to separate the digits into 6, 1, 3. We're going to keep this 13 as its own digit because technically it is. That's what the letter D is in hex. So then what did we do? We made subscript placeholders starting at 0 in the least significant position and then increasing as we move to the left. And then we take this digit, 13, and we multiply by our base is 16 raised to the subscript. So then we take our 6, multiply by 16 raised to the first. Okay, so anything raised to 0 is just 1, so this will give us 13. 6 times 16 is 96. So then for our final step, we're just going to add these straight down, and we should get 109. So therefore, 6D in hex is equivalent to 109 in decimal, in base 10. Okay, great. So then how about a bigger example? Let's do this again, but this time let's convert 32BF in hex to decimal. Okay, so the first thing we do is we write out the numerals of our hex number, and we write a placeholder subscript. So our numerals are 3, 2, B, F. Now we look over here at our hex guide, we see B is kind of like decimal 11 and F is like decimal 15, right? So I can write this as 3, 2, this is going to be 11 and this is going to be 15. Now, like I said before, don't separate the 1 and the 1 and the 1 and the 5. These should really be grouped together because they're their own digit. Okay, great. So my placeholders, 0 at the least significant bit, 1, 2, 3. As I move to the left, it gets bigger. Great. So then I take this digit, this is 15, and I multiply it by 16 raised to the 0 because 0 is the subscript on 15. And then I'm going to take the next digit is 11, multiply by 16 raised to the first because 1 is a subscript on the 11. Then I take the 2 and multiply by 16 to the second. And finally, I take the 3 and multiply by 16 to the third. So this is going to give me 15. This product is 176. This product is 512. And this product is 12,288. So my final step to get the conversion is I'm just going to add all these products straight down. So the sum of all these gives me 12,991. Therefore, 32BF in hex is equivalent to 12,991 in decimal base 10.